Hello YouTube, this is Dazza the cameraman. Today is Saturday the 2nd of November 2013 and this is a Comet ISON update. As we can see as of today's date, and this is a live view in Starry Night Pro, we can see that Comet ISON is crossing the orbit of the Earth, which is this green line here. Comet ISON is the blue line, the trajectory of Comet ISON there. Now of course there's been a whole lot of crazy videos being uploaded to YouTube and being posted all over the place claiming that Comet ISON is going to hit the Earth and that we're going to go through all this debris from its tail and it's going to cause all sorts of problems, and of course all of this is nonsense. It's absolute rubbish. We're going to take a closer look at Comet ISON in this video and have a look at what's really going on. In this view we're looking at a 2D view of the inner solar system out to Mars, and we can see the trajectory of Comet ISON as it's coming in. But of course, being a 2D view, it doesn't give us the real story of what's really going on. But if we have a look in 3D and zoom in, then we will have a better idea of what's really going on with Comet ISON, where it's going in relation to the Earth, and what is and isn't likely to happen. So first of all, let's zoom in and take a closer look, and when I zoom in we'll see the tail appearing, and there it is. We can see that tail crossing the orbit, the trajectory of the Earth, this green line here. So should that be a worry? Well, no, it shouldn't. Let me just zoom back out again and we'll take another look. This time we'll have a look in 3D. What I'm going to do is tilt this up, so now we're looking in a 3D view, and what we see when I zoom in is that the Earth doesn't actually really pass through the trajectory of Comet ISON at all. In fact, the orbit of the Earth, as we can see here, actually passes well below the trajectory of Comet ISON. Now if I zoom in again, the tail will appear, and we can see from that the Earth's trajectory does not pass through the tail at all. Remember that the tail of a comet will always point away from the Sun. This is because of the pressure of the solar wind pushing those particles away from the Sun. So we have no chance of actually going through the tail of Comet ISON at all. Okay. Now remember that in this view it doesn't look like the distances are very great, but we're actually talking about millions of miles or millions of kilometers here, okay, between Comet ISON and the trajectory of the Earth. In fact, if we did pass through the tail, it wouldn't matter anyway. Back on the 19th of May 1910 we actually passed through the end of the tail of Halleys Comet, and back then the doomsayers and the scammers were conning people into buying comet pills and comet umbrellas and all sorts of things, because people were fearful of what Comet Halley might do. The same thing as has been said now. There were claims that cyanide gas or cyanogen would snuff out all life on Earth, and of course that wasn't the case. We're still here. There were no ill effects of the Earth passing through the tail of Halleys Comet back in 1910. You can Google that yourself, have a look at it, and check it out. So this is today, 2nd of November, and of course the Comet ISON is going to be heading around the back of the Sun on the 28th of November, and then it's going to be heading out. So let's step this forward, and we can see Comet ISON. Unfortunately this is spinning around because we're looking not from a fixed location. So now Comet ISON is actually heading back out. I'm going to take this out until it's back up to the Earth's orbit. So back round about the 26th of December I think was the closest approach to the Earth, if I remember correctly. And again, let's tilt this up and we'll have another look. And we can see that Comet ISON is well above the orbit of the Earth. Now remember that the planets rotate around the Sun anti-clockwise, so we're actually going around this way, and we can see that Comet ISON in its orbit is well above the Earth there. And again, if I zoom in so we can see that tail, there we go, there's the tail, and again it's pointing away from the Sun, it's not pointing towards the Earth. As I zoom out we lose sight of that tail, but you get the idea there that there's no way that we're going to be passing through the tail of Comet ISON. Not that it would matter if we did. In fact, it would be quite good if we did, because then we might see quite a nice meteor shower, so I'm a bit disappointed that we're not actually going to go through the tail. But anyway, everybody's been making a big deal about Comet ISON, but they seem to forget that within our inner solar system there are presently more than 220 other comets within our inner solar system, and nobody's talking about them. They're all just making a fuss about Comet ISON for some reason. Same thing happened with Comet Elenin. They made a big deal about Comet Elenin and said that it was code for ELE-NIN, extinction level event, Nibiru impact near, and various other nonsense. There's actually another comet within our inner solar system, one of many, which is Comet Lovejoy C2013R1, and I've been having a look at that today through the Slooh remote telescope, and I've taken some images of it, and I thought it would be interesting just to have a look at Comet Lovejoy while we're at it. As we can see, I've turned on the orbit diagram there so we can compare that to Comet ISON, and we can see that Comet Lovejoy has quite a different orbit from Comet ISON. The angles are very different, and another thing that we can see is that, and I'll just reset that today's date because that's on December 26. As of today's date, Comet Lovejoy is actually a lot closer to the Earth than Comet ISON is. So here's Comet ISON, here's Comet Lovejoy. So if I check the distances between the Earth and the comets, we can see that between, let's get it on the right one, between the Earth and Comet Lovejoy there's a distance of 0.606 AU. Now 1 AU, that's 1 astronomical unit, is the average distance between the Sun and the Earth. So that's approximately 150 million kilometers, or 93 million miles. So if you want to work out the distance in kilometers or miles for any object that's so many AU away, you need to multiply the distance in AU by either 150 million kilometers approximately, or 93 million miles to give you your distance in kilometers or miles. So there we have 0.6 AU, which is just over half the distance to the Sun, between the Earth and the Sun. Or if we go out to Comet ISON as a comparison, we can see that Comet ISON is 1.194 AU away as at today's date. So we have Comet Lovejoy is quite a bit closer to the Earth than Comet ISON is at the moment. So let's have a look at some pictures. This is a picture of Comet ISON that I took just a couple of hours ago through the Slooh robotic telescope. You can join up and become a member for $20 a month. That's quarterly. And this is through the Slooh T2 wide field telescope. This one is through the Slooh T2 high mag telescope. So there's a comparison for you. But let's have a look at Comet Lovejoy, and I'll switch between the two images that are from the same telescope so that we can get a good comparison. So this is Comet ISON through the T2 wide field, and this is Comet Lovejoy through the T2 wide field. This is Comet Lovejoy through the T2 high mag. So if I go back to Comet ISON, that's ISON through the T2 high mag, and this is Comet Lovejoy through the T2 high mag. And as you can see, they've both got this green color, which is not unusual for comets. It's quite normal, and I just find it really interesting that people are making a big song and dance about Comet ISON, but there are plenty of other comets within our inner solar system right now. As I say, there's more than 200 of them right now within our inner solar system, and that's nothing unusual. But everybody's making a big song and dance about Comet ISON, just like they did about Comet Elenin. Here is a closer look at those images. This is Comet ISON through the T2 wide field. This is Comet ISON through the T2 high mag. Comet Lovejoy through the T2 wide field. And finally Comet Lovejoy through the T2 high mag. So there we have it. That is an update of where things are at with Comet ISON and Comet Lovejoy. We can see that Comet ISON has just crossed the orbit of the Earth, and it is actually above the orbit of the Earth, so we're not going to be passing through its tail. It won't be changing trajectory when it goes around the back of the Sun and coming off in some strange direction. All of the factors of its trajectory are calculated very carefully. You know, if we can put spacecraft into orbit and send them around distant planets and far out into space, then we certainly don't have any problems calculating the trajectory for a comet. And the fact that I can enter the coordinates in the Slooh robotic telescope and have the telescope point at this thing based on projections that were done weeks and months ago proves the fact that these trajectories are accurate and that there's nothing to worry about. In fact, I've been planning to do another video showing how I've been downloading the trajectory data for Comet ISON over the last few weeks and saving it. And what I'm going to do is a comparison of the trajectory data from then and in the future, and we'll see just how much the trajectory data has changed as Comet ISON heads round the back of the Sun and heads on back out. And we'll find that the trajectory data is actually pretty accurate. As always, do check out my Facebook discussion page, Voices of Reason to Explain X or VORTEX. I'll put a link in the description box for you. Thank you for watching.